Okay, so here we are for the second one. Changed up though. This time they're throwing it down. So we have an initial and a final this time. So same equation. It's the final speed squared, initial speed squared, plus 2 times a delta x. And of course, since you're throwing something, a is equal to negative 9.8 meters per second squared, you throw a dart straight down from the top of a building at 10 meters per second. So your starting speed is negative 10 meters per second. Negative, it doesn't say negative here, but if you're throwing it down, then we know it's going at a negative speed. When it first leaves your hand, it's already going at negative speed. By the time it hits the ground, the dart is moving at 44. So the final speed is negative 44 meters per second. So you know it's going to be heading downward, of course, right the second before it hits the ground. That moment right before it is going down, of course. So and they said at 44 meters per second, and they want to know delta x. How high is the building? So we're looking at a position change. They're wondering how much did the object change position from here when it was going negative 10 down to here when it was negative 44, the whole time accelerating at negative 9.8 meters per second, correct? Meters per second squared. So they're looking for that distance change here. Let's plug it all in and see what happens. Negative 44 squared is equal to initial speed negative 10 squared plus 2 times negative 9.8 and delta x. Okay. So this right here is going to be negative 19.6 delta x. And then right here, negative 10 squared is a positive 100. And 44 squared, that's going to be a large number. Let's see, 44, and then square it right here. Did I put 444? I'm not sure. I think I did. 44 squared. There we go. 1936. 1936. There we go. And what do we do next? Let's get rid of this thing here. Negative 100. Take away 100. That's 1,000. Take away 100. And that's 1836 is equal to negative 19.6 delta x. Now let's divide by that negative 19.6 and then divide by negative 19.6, and it's going to be a negative number, which makes sense. The object will be below where you left it, right? You threw it downward and it's heading downward. It should be negative, so these numbers always end up working out. So delta x is equal to negative something. I just know it's going to be negative something. Let's figure out what it is. 1836, because we minus that 100. So that's 1836. Then we're going to divide by that 19.6. I'm not going to put negative because I already know it's going to be negative, so I wrote it down already. Like I said, I like to keep track of that on the side by myself. And then I get 93.6 meters, or 93.7, I guess, if I round. 93.7 meters. And that's it. So that's the change in position. Although, since they asked you how high is the building, you could technically answer 93.7 meters and you would get the correct answer as well, because they're asking for how high the building is. They didn't ask for the change in position of the dart, which was negative, and it changed position from here downward. They're asking for the height of the building, which would be normally given in a positive number, not a negative number. So it's fine either way. And that's it, folks. So try out your sample problems now.